So my memory says today we need to do rigor and reproducibility. What do you know about rigor and reproducibility? This one's not going to be as much fun as stats, sorry. What do you know about rigor and reproducibility? Now you can see I've gone from my typical slides to the CCTS typical slides. What do you know about rigor and reproducibility? Nothing. That what you're telling me? Nothing?
The NIH is starting to require training in it for.
Yes, and we run that through the CCTS actually.
You guys have a great Python game.
That's what we do. Do you think it's great? Because I need some feedback because Vanderbilt's about to launch it and use it, and I'm the guy that wrote all the questions, and I'm the math geek. So some of those I don't know. I don't know if they're great questions actually. But the context of rigor and reproducibility is exactly what was stated. It is NIH. Certainly, I'll go through the history of it. Several years ago, NIH added review criteria to the grant process or the grant application process. My comment to you is, even if they hadn't, we should be doing this anyway. Okay, we have been trying to do this. I'm going to crack the doors, not close the doors, but my voice does boom. Through the CCTS for years, through our panels program, through consultation with the bird. There were some components that we weren't good about, but we'll go through them, okay? So here's the history of it. It's hard for me to believe in 2014. I'm going to tell you the absolute truth, how I became the rigor and reproducibility guru on this campus. 2014, there is this article that comes out in Nature. Well, they know how to get their press, don't they? In Nature, to say that they need to do certain things, that they believe that certain things are going off the rails, and that research is no longer, or science is no longer self-correcting. And they were going to put certain things in there on the review process, a checklist for the analytic approach. We've already had written for years. I've been sitting on study section, right, reviewing literally what's the statistical analysis plan. And you don't know how many times I had to write this analysis plan is completely disjoint from the specific aims. They do not align at all. It was a cut and paste of a previous analysis plan. Or I would write things like, yes, they've thought it all the way through. I would recommend this possible, possible extra analysis just to be extra secure in your interpretation. That was going on. They came up with all these measures or all these plans. Then they released the RFA in October 9, 2015. That said, on and after January 25th, 2016, these will be enforced. These 4 new things will be enforced and required for all applications into NIH. Now for the piece that you don't know, and it's interesting because boy, they got people's attention. Here's how I became the guru of rigor and reproducibility. And I'm not the guru, I'm just making fun of myself. I still violate half the stuff I'm about to teach you. But I was about to go get in the car and drive to Virginia, of all things, for Thanksgiving. We were going to have a nice Thanksgiving with my in-laws who live in Virginia, and we did have a nice Thanksgiving. But I had a friend who I went by and just said, hey, I want y'all to have a great Thanksgiving. And Dave, I need your help. Oh, what? I've got to do this presentation on rigor and reproducibility, and I don't understand half the stuff. Could you do half the presentation? Oh, sure, no problem. This is March 20th, 2019. I'm still talking about it. The irony is that that night that we did the talk, We had people fully packed out. It had to be broadcast into the foyer, down the hall. We had to put a TV back there. It was standing room only, and there were people who were in the street that walked away because that's how important this had become. This is how concerned people were. I'm not going to make you read the RFA. RFAs are very boring. Well, with the purpose, all applications, all of them, were to now have an authentication of key biologic and or chemical resources. That's interesting. What is that supposed to mean? Especially, what does that mean? There are going to be rigor and transparency questions. They completely revise the application, and in NIH studies, now that when you go to study section, you get the questions. Scientific premise. Have they discussed sex and other biological variables? Is this a study that needs authentication of their chemical agents or biological resources? And then finally, the statistical rigor. But usually that statistical rigor has already been discussed, because that was, who do you think reviewer 3 is on your grant? It's usually a methodologist that they brought into the room to make certain power is correct, analysis plan is correct, that the aims lead to the analysis plan, and the analysis plan then leads into the power calculation, and that the bridges have been built. Major problem is when there are disconnects. Here's your hypotheses, you got the correct analysis plan, and you choose to do the simplest power calculation out there that has nothing to do with your aims. It happens. So, what are the score criteria? These change your score. These things actually change your score. They are to go into the criteria of whether you're assigned a 2, a 3, maybe you get a 1. How do you get a 1? 1, 2, 3. This is going into that mental calculation that I have to do when I assign scores for NIH. Is there a strong scientific premise for the project? What do you think that means? We'll go into it, but what do you think that means? What's a scientific premise? I'm still recovering from spring break. The undergraduates, with all due respect, the undergraduates rebounded faster than this.
They're younger.
So what do you think the scientific premise is? What do you think it is? Oh, we're friends. This is lecture number 3. We're going to be lifelong friends. Come on. What do you think it is? You're on the right hand. What do you think it is?
That the study is based on sound evidence?
On sound evidence, but hear me very carefully. It is more than that. Most people will say, but dadgummit, we've been doing a lit review for years. This is not the lit review. The scientific premise is actually an assessment of the strengths and weaknesses of the experiments that are in the literature that you are relying on for this application. You're also saying where the gaps are. You're not throwing stones, but you're literally breadcrumbing it. Pardon the expression, I don't know if that's still a true term. You're breadcrumbing it so that people see how all these things lead to this specific question, and they can judge for themselves the strengths of the previous research and the weaknesses, as well as the strengths and weaknesses of your preliminary work. Your preliminary work is part of that scientific premise. So you need to be able to talk about where you've done it right and where you've done it wrong. You need to be able to do it better. Robust or non-biased approach, right? That's pretty much the statistical approach. Have the investigators presented adequate plans to address relevant biological variables, such as sex. That's the one they always do. Or, I point out, you also got to keep up with age. age matters tremendously for studies in animals or human subjects. Now wait, time. I also do the traveling show for this. I had to go to Auburn to present this. They asked me to come down because they too were getting, lit up like a Christmas tree on some of their reviews. We're not having to address this in their animal studies. And man, I did my presentation, here comes question and answers, and out came the knives. Sorry, you are going to bankrupt the school, the veterinarian school, because you're saying we've got to double all of our studies and test for sex differences. I didn't say that. That's what they heard, and I understand that that's what they heard, but that's not what I said, and that is not what NIH has said. NIH has not said you must test for sex differences. Bottom line, they're just saying, go to the literature, look at the animal literature from 10 years ago. They don't even tell you if it's all male, is it all female, you don't get the age of the mice. You've got to be very specific. Where is all this coming from? Because there is a perception, which is, in my opinion, valid but ill-defined, that we cannot reproduce our science. That once something is published, when someone else tries to go do that exact same experiment, they don't get the same results. My comment to that is the old Native American proverb, you can't step in the same river twice. You shouldn't expect to get the exact same results. If you did, I would accuse you of fabrication. If you came down to the exact same numbers, but what they're getting to is there's not sufficient documentation of the experiments to allow people to have a real chance of, hear me, replicating. I don't like the word reproduce. I have a different definition of what reproducibility is. And you will see that in some of the Kaizen questions if you ever get a Kaizen thing. So these are all, you blow any of these, your score goes down. You leave out sex as a biological variable, and if you say I'm doing only females without a justification for it, they're going to stop you. That should bring you out of the funding range. Period. Now, does that mean you can't write a grant or say I'm only doing a specific sex? The answer to that is, of course not. You just heard what I said. You've got to have the justification. We are actually doing a rigor and reproducibility 4-week course for one of the T32s. There's about 25 students in there, and we've broken it down where we're using the Kaizen game, but on Mondays we do a full lecture on each of these. The comment was made, and this week we were doing, 2 weeks ago we did stats. This week we ended up doing sex as a biological variable. And the question came up. Is it reasonable to say we're studying breast cancer and we're only going to study females? Is that reasonable? And that was a question to the students. And of course, whenever professors ask questions, it's correct. So the question is to you, is that fair? Would that get you balanced? This is the point where I stand here in an awkward silence. What do you think?
I would say you would have to add more as far as justification of why you want to study just women, because men also can have breast cancer.
Exactly right. And I like the way you said it. You need more. It's not that if you go in there without addressing it, you're going to lower your score. Do I think that would be in such a case like that when we're saying, and most people recognize that 99% of breast cancer occurs in female, but there is 1% of all breast cancer is actually in males. In males. But you could say that it is so rare that this study will focus and enroll only women. But I would argue that if you were doing a pathology study and you had pathology specimens for males, you need to be able to say that you would use them. But if you go to a prospective trial, I can understand. But those are the type of things you've got to be able to reason out. Then this is the one that doesn't get scored: the authentication of key biological and chemical resources. How many of you are using chemical? How many of you are using cell lines? No one. One cell line person. Anybody use chemicals? You use chemicals? Okay. I'm going nowhere fast. The idea is this. I love to bake. I know that sounds crazy. I have 3 daughters who spend a lot of time lowering dad's blood pressure from things frustrating him at UAB by spending time in the kitchen over the weekend baking stuff, trying new recipes and doing all those things. My middle child loves to make cakes from scratch. Fine. Frustrates mom. We make a mess in the kitchen, but we'll get around to cleaning it up soon. What's the first thing you need to do when you are going to use baking powder?
Make sure it's not baking soda.
Make sure it's not stale.
I said make sure it's not baking soda.
No, baking soda. Actually, they require. I know they both require. They're both required actually in this, but they're both required in a very good pancake recipe that we have. But what do you have to do with your baking powder? Baking powder expires. Baking powder is designed that when it hits the liquid, it will release carbon dioxide. That gives the lift to your cake. Stale baking powder means flat cake. How do you test it? You always take a pinch. You drop it in the water. Just a pinch, drop it in a little bit of water. Look, does it foam? Does it fizz? Double acting baking powder, people wondered, first releases the first dose when it hits liquid, then releases a second dose when it hits a certain temperature. So you get a double lift. All the authentication of chemical reagents is simply that. Are you testing your baking powder? If you're using chemical resources, or if you're using cell lines that you say are cancerous, or are from a specific tissue, are you double checking? If you're using cell lines, and are you sure they're not contaminated? That's one of the things that's very scary. There are articles out there that says the immortalized cell lines aren't what we think they are. That they may have genetic components in there that have nothing to do with cancer. And we're studying the pseudo. Those are the types of things. Here's where it goes wrong. Okay, this is a separate document. This is a separate document that has to be uploaded. This is a separate form. There's only one person in the room that needs to upload it. But all of you have to. All of you are required in submissions to have this form. And if it, yes, I agree, I roll my eyes too. If it does not apply to you, do you know what you do? You upload the phone with a one line that says, this does not apply to this training. But it has to be there before I go through it. Can't be submitted. We have examples online for if you have colleagues that are running into this, send them to us, but we have examples of people who have written out their forms for chemical and for the authentication of key biological and chemical resources. I can point you to people that can help you do that. The key thing is to remember this one thing about it, this key one thing. It's not one and done. In other words, don't say at the beginning of my 5-year grant, I'm going to test this new batch that has just come in. You need to have a schedule laid out that every quarter, every 4 months, whatever makes sense, here is the protocol that will be implemented again to make certain we have comparability over time. All right? So the revised grant applications gave us the instructions highlighting these needs. Then it went to the reviewers to consider such details, and I'll show you where these things have to be. And these are your 4: scientific premise authentication, relevant biologic, rigorous experimental design for robust and unbiased results. Okay. So going forward, before I said this to you, for an application, describe the general strength and cited by as crucial to support the application. One of the questions on the Kaizen game is if you're doing a study of opioid receptors in the brain and you were going to hypothesize, because it is a known demonstrated fact, that African Americans, for the exact same stimulus, but a little heme element, not going to burn anybody, put it on the back of the arm, you age match and gender and sex match, male, and you do it all, and the only thing that's different is the race. Give the exact same stimulus, African Americans will report far more pain, far more big than the other races. And that is very solid. But suppose you're going to build this research grant that says it's due to a change in the opioid receptors of the brain. Think about that. How would you build a scientific premise for that? Think about it. You got to be able to cite the literature indicating there is a racial disparity of pain. But then you've got to come in and also demonstrate that there is some reason to believe that by genetics or either by environment, something has happened that would alter or decrease the number, alter the capacity or decrease the number of new opioid receptors in the brain. The reason I'm citing those two is we designed that study. So those would be the things there. You have to go to the literature and talk about how many experiments are out there that are doing this, what were their preliminary things, how strong is it, and go from there. All right? Any questions about that? You know, I'm very quiet today. I already said this one too, the authentication of key biologic and or chemical resources. That's the key thing. The first 6 months, we had to do it. We had to throw it in and see what happened. And we did. And what happened was we got slaughtered. We did our best, but we were doing these. We're going to do this on day 1. Here's our plan. Everybody, all the time we were coming back with. This is and by the way, this would not stop the funding. Then you get dinged on this one, you will still get a fundable score. They just won't give you the money until you fix this. That's the truth. They will not give you the money until you fix this. And then we had a few held up for this, and we got on the phone with NIH and said, what's the problem? Well, we think it's great, but you indicated you're going to do it at the very beginning of the study, and then you never said you would do it ever again. It read as if we're going to do this, and we're checking the box, and we're never circling back to it. And you know what? I said, right, the way we wrote it. Good point. You want to be honest? Can I be honest? We wrote it that way because that's what we were going to do. That's what we had in our head. That's what we had in our head. That's what we thought. But we'll do this. And we hadn't thought about how, we thought about how to do it, We didn't think about how often to do it. So we learned from our mistakes, I hope. Please keep in mind cell lines, antibodies, all these other things. All of this has to be discussed. One of the things I found really interesting, one of the researchers that we were talking to in the Rigor and Reproducibility course actually gave the example of he ordered a specific strain of mice from a catalog. So he had the number for that strain of mice in the catalog. So the catalog order number. 6 months later, he needs more. So he just literally hits the same order. Renew this order, send me more. In that 6 month period, that number had been reassigned to a new strain of mice. So now he's looking at all these going, what the? Trying to figure out what's going wrong with his experiments until he actually goes back and he looks and realizes, yeah, he ordered by the exact same number, but he didn't do his homework to make certain that that number had stayed with the strain that he wanted. But like I said, we learn from our mistakes. And the other thing is, please understand, all of this sounds like this should be sitting only in the NIH applications. Why do we get NIH applications, guys? The door slightly cracked. Hey, Gene, am I being broadcast?
Yes.
Okay. Yeah, I'm going down. Why do we get NIH applications? I'll say it. Because we want to do good science and we like the money. But how do we do good science? We do the experiments and then we have to do what? Publish. We've got to publish. All of these things that we're talking about need not only to be in your grant application, but discussed in your publications that will allow individuals a better opportunity to reproduce or replicate. That's the whole idea. All right. Like I said, I've already given you my Auburn story. Please keep in mind, everybody focuses on sex. You should also talk about age. And if you introduce it, my attitude and my approach to it in all the grant applications has been very straightforward. It has been, I am going to, it is an animal study, guide them toward having equal numbers of the sexes, that we will put it in, the sex variable in as a covariate. In other words, yes, it may create some variability, but I can absorb that as a statistician. I have techniques to take care of that. And furthermore, if I put it in there and it doesn't absorb anything, what did I just confirm? Sex is not a driver here. Okay? If it does nothing, then I can step back and say, well, I've done it. I've measured the variation, and I've done it right. And yet we don't have it. But if there is indication there, then that may be worth reporting to say, hey, be mindful. We saw, it may not have achieved statistical significance, but it accounted for non-trivial amount of variance in our outcomes. But at the end of the day, I typically always insist, because you think about it in a human study, we always go and insist that we have both sexes. We say what the age range is. We insist on diversity of the races, which is all appropriate. But in every analysis plan I've written in my 24-year career, if we were doing human research, I said analyses will control for sex, race, age. They're just pushing this down onto the animal studies. That's what they're doing, and I think they're doing it appropriately. And now the problem here is human studies usually have far more individuals in them, giving me more degrees of freedom. Animal studies don't. One of the things I've pointed out over and over, I don't understand why we always do 3 and 3 in animal studies. Where did that come from? I get sample sizes of 6. I can't do it. I can't even check normality off of 6 observations. Yes, ma'am.
I just have a question here regarding like human research.
Okay.
So there are, just bunches of papers, especially if they're doing like randomized control trials,
Randomized controlled clinical trials.
where their patient population is not representative of.
So this is a generalizability question.
Okay, so how, when you're like, I mean, even ones that happen here at UAB, right? How, when you're writing the grant, do you, because I mean, it's basically lying. If you say you're going to use equal men and women, if say you're doing a study that's like at the VA where it's mostly men.
My comment is, all right, that's an excellent point. And I've said that before. I've done VA studies.
Yeah.
I've studied their EMR.
But like,
I'm lucky if I can find 4% female.
Yeah. Yeah.
It's staggering.
Yeah.
And you have to acknowledge that as a limitation.
But like when you're writing grants to do these studies and you're saying, I'm going to use a VA population.
Then you have to come back, you come back and you acknowledge it and say, it is a true fact.
Yeah.
Unbiased, unapologetic, sad fact.
Yeah.
This population is 95% male.
But you write that in there.
Yes, I would.
Okay.
I would first, this can be recorded. I do everything I can not to lie.
Yeah.
Period.
Yeah.
Now, I'm not just talking about with regard to publications, and I'm not talking about to the NIH, to whoever I'm dealing with, even if I got to tell you something that you don't want to hear. I'll try to say it as nicely as I can. I'm a firm believer. If we could just say the truth, we get along a lot better and get going a lot faster. So, sorry, that's me and my soapbox.
But you then, so as you, somebody sitting on the study section,
I would accept that.
reading it, you're like, look, this is a fact. They're 95% male, but they want to use this population. What kind of, I guess, how do you get past that? Why can't say they use a different patient population? Like, how do you as the reviewer then say, well, VA, SHMEA, use somebody else? You know what I'm saying?
I could say that, but at the same time, I can turn that argument around and say that the VA represents a unique population that merits study. I think you have to be very clear in the limitations and why, and it goes back to the scientific premise. Why would you want to limit to the VA? In your scientific premise, if you can say, being recorded, I'm studying the VA because the VA was one of the first ones to introduce the opioid restrictions. And it is probably the beacon that we can see any signals for how this policy has affected the public health of this group.
Yeah.
And then I restrict it to this group. One of the things I can't get around, and this is one of those things, is, again, for generalizability. You want your research to be as generalizable as it can be, so you try to make it in kind of this, one of those dueling wars. You want homogeneity, a very tight group that has little noise in it, so you get the opportunity to see the signal. And generalizability says, can you see the signal in noise? That's a dynamic you have to work with. I would argue if you clearly define your population that you are working with, and someone goes to the exact same population and has all the information necessary to reproduce your experiment and do it, and they see it also, we have got reproducibility. If you have the defined population results, and this person replicates your in a different, goes to a different population, and it doesn't appear, I would be hesitant to say we failed on reproducibility. I would say we question the generalizability.
Mhm.
Those are the differences, because when you move between populations, you're now talking about generalizability. Don't have to raise your hand, we're all friends.
Oh, sorry.
This is third lecture.
Was somebody else?
No.
Just me. Okay. So then when we talk about, so that's my question about human studies. So then when you talk about animal studies, a lot of the stuff that's coming up now is like, we all use these mice that are on black 6 backgrounds, right? No matter, like, whatever they are, a lot of them are on black 6. But we know for a fact that there are differences between these different strains of mice, especially when it comes to interventions with like pharmacologic agents, right? And so how now, when you're writing a grant, you're not writing it, you're helping someone write it, how do you address this question of this pharmacologic agent on a black 6 background has this effect, but we know from previous literature that maybe there's been some data on, a different background that it has a different effect. Like, do you have to now address that? Okay.
I wouldn't hide it.
Okay.
And then I would have to sit down with you and literally talk about, can we do a study if you're concerned about that, broaden it and let's do a test of interaction to see if we're actually seeing that our treatment and treatment's impact on outcome varies by background. That's a test of interaction.
But like, when you're writing, so say there is no previous literature, do you still address it or not?
I would address it. Yeah, I would always address anything that I have a concern about.
So where do you stop? It's like, there's like hundreds of strains of mice, You say I'm gonna test it in every single one. I mean, there are
no, you can pick them, you can literally pick the one, you said black 6?
Yeah, that's like just common.
And then what's the other two, what most common behind it?
I don't know.
LC.
LC is a common
AJ.
one.
Compared to those two, just do it and just see.
Okay.
I mean, I know I'm pulsing you, but this is where they're asking us to go.
So have you seen that yet?
No, I haven't.
Okay. Maybe we should just erase that part so that they don't think about it.
No, let's not do that. So then we got the thing here with regards to, this is why we have the park clinics Monday and Wednesdays for the rigorous experimental design. We've got to talk about randomization, blinding, all of these things. And yes, I discussed all of that in the stats sections for the applications. How missing data will be handled, what we're going to do with regard to inclusion, exclusion criteria, all of these things. And this is the breakdown of where it would applies to which applications. All, it's pretty rigorous. I mean, it's pretty broad. Every NIH application has to talk about scientific premise, scientific rigor. It has to be in the research strategy section. It should be in the significance. The significance is where you are building your argument. It's right after your specific aims page. They're expecting to see scientific premise. In the approach, they have to, in the approach section, we need to come back and talk about statistical. Here, interesting, sex is a biological variable, has to be also in the approach. And these are the questions that are asked. These are your questions. Is there a strong scientific premise? They don't say stat, they just say robust and unbiased approach. And then this And then the final is they will comment on your plan. They will not score your plan for testing your baking powder. This is one of the key things I like to do, though. This is why we need to come back and discuss. This is part of the paper. There's a paper out there called How Scientists Fool Themselves. And I think, again, we can do all of these types of things, and we can do it right, but we've got to be careful about our inherent biases. Don't get married, well, let's put it this way, don't get to the point that you're so convinced that your hypothesis is right that you've lost your open-mindedness. That's one thing that people argue is going on in the literature, is you are so convinced that you will not even consider another possible explanation for what you're observing. The one I tend not to have this issue, honestly. Bottom line, I have problems where when I'm assisting people at the end of their study, they've collected all this data, I do their first set of results and they're all null. There's nothing there. Though we designed the experiment right, we did everything that we could, it's a null finding. What do they immediately do? Do they immediately come back and say, okay, produce the table so we can submit this for publication?
Regression analysis.
Hey, how about this outcome? And we just start pulling straws. We keep going. Oh, let's go to our secondary analysis. That's not right. You're now fishing. You're fishing for significance. I fight that every day. I'm an honest guy. Sometimes I choose not to fight. That's what you want, let's go. But we've got to resist it as a team. I am terrible about this. I make this mistake all the time. Asymmetric attention. I go and do the analysis. The p-value is statistically significant. Ready to meet with you. Let's go. Without going and double checking where, looking at those plots one more time. Are those assumptions holding? Do I really see normality in those residuals? Do I really see homogeneity in those residuals? Am I certain that there's not an influential point? Have I done my homework? Whereas if the p-value is non-significant, you know what I immediately do? Well, let me check those residuals. I might need to go to a non-parametric. Oh, let me see. Oh, is there, look. Hey, investigator, you got an outlier here. Blowing your variance up. Do you explain this? Can't do that. The strategy is the strategy is the strategy. Okay? When you get these expected results and you say, oh, I don't continue my investigation, I just got it. Whereas when you don't get your expected results, you start mining deeper, you got to ask yourself, are you doing exactly what you wrote in a pre-specified plan? Well, there's actually a textbook out there that I keep referring to that talks about just so storytelling. It's not very nice. So I have a psychologist in the room. Okay. That psychologists love to do factor analyses and see how certain questions load, and this factor clearly represents self-confidence, and this factor clearly represents self-esteem. The end of the book on factor analysis says, I mean, this is a factor analysis textbook, and the statistician says, the real proof is you've done a good job if you hand it to somebody and they say, aha, it makes sense. I can tell a story. Please avoid that.
Can I ask one more question?
You can ask as many questions as you would like.
Sorry.
I'm
So-
here for you.
When you're helping people write analysis plans for things where they're going to do analysis on data that has already been collected, I think that that's probably where you most often have people falling into this trap of like, let's check this, let's check this, let's check this.
Mhm.
So what kind of analysis plan can you write, like, to give yourself a good chance of finding something, but avoiding this like fishing?
Okay, so I do that actually all the time. And that I should probably put some of my analysis plans out there on the CCTS. The reason I don't want to, people are going to cut and paste and drop them. But if you read my analysis plans, let's say I've got a continuous outcome, I will state the primary approach will begin using multiple linear regression and with the following covariates, period. Careful examination will include, or we will carefully examine potential other covariates prior to building the model to see if they either have an association with the outcome that we did not anticipate or with one of the predictors. So that gives me the reason to go and do more homework. But I've said what I'm going to do. Then I will build the model. I will check all distributional assumptions. I will check them by looking at normal probability plots. I will check them by looking at histograms, and I will check them looking at residual plots. If any of the assumptions are violated, notice the conditional statement, if, or if the assumptions appear questionable, we will proceed. So I'm saying exactly, here is the road, here will be a fork in the road. I don't know which fork I'm going to take, but I will decide, tell you how I will decide which fork prior to going. But it is, the other thing that I find it really hard to do, and I don't mean this bad, after very large studies, people, there is so much data there. Well, we'll do this paper. We'll do this paper. That's fine, but I've actually had people who have said, I want to use this as the outcome, and this is a predictor. And I said, that makes sense to me. We published it. Right after publication, they said, now I want to do this. I want to use this as the predictor, as the outcome, and include this over here in the covariate set. I said, no way, you can't do that now. But it happens, and you just got to keep asking yourself over and over, what's my rationale for doing this? The other thing is there are certain techniques. You can put out your data, you can pre-write your data analysis plan, you can try to be your own devil's advocate. Take your data, ask yourself, if I did not already have a hypothesis, if I had not, could there be another possible explanation of what's going on here? The team of rivals, I don't like rivals. I kind of would have, if I had written the paper and I didn't write the paper, I would have combined blind data analysis and the team of rivals, because the bottom line is you don't have to have a rival. You can have a colleague. And a colleague to be able to say, I've done this. Before I go publish this, before I go any further, can you look at it and hold me? I hate, what word I really hate? I hate accountability. I hate that word. But can you work with me here? Can you collaborate with me and take a look and see if you think I've pushed it too far, or that I've done something that you don't think is justified? And the other thing is, honestly, I do this on very large studies. I hope the IRB's not listening. I'll come to the clinic and say, hey, can you give me 45 minutes? Here is the data set. It's ready to be analyzed. Okay, but David, the group's labeled A and B. Damn straight it's labeled A and B. I've already run this. I've done my complete set of analyses. I knew, because I was a statistician, I was not blinded. I knew what A was. I knew what B was. You do this completely independent of me. You tell me, do you see a treatment effect, and what did you adjust for, and why? And compare the two. That is extremely robust. Now I'm going to get on my soapbox before I'm going to let y'all go in just a little bit. Is this. Reproducibility has a different definition to me than everybody else in the CCTS. How many of you are we submitting abstracts anytime soon? Anybody got an abstract going in? Anybody submitting a paper anytime soon? Anybody going on vacation soon? If you are, one of the things I try to do, and if you will go look at mine, I can't let you see it, but if you saw the structure of that computer, you'll see that each of my investigators has a specific folder, and then underneath their inside their folders are their studies, and inside their studies are ENAR _ 2019 _ archive, which means somebody submitted an abstract to that conference. Struggling with words, lack of sleep. Inside that folder is everything, the analysis ready data set that was used to produce the results, the raw data set that came to me, the analysis that I conducted, everything that is needed. So in 6 months, when I get a call that says, oh my gosh, where did these results come from? I can reproduce. Another thing that's an issue in literature is you contact people and say, can I have that data set? Can I look at that? Can you? And they say, we don't have it. What do you mean you don't have it? You published it. So always, and I'll be very honest, I know there are some studies that were done here that if we were told you have to produce the final data set that was used for the paper, we would have to go through a set to try to identify it. It is not clear. So when I want you to also think about reproducibility as being an archive, before you ever submit abstract paper, always have the archive, have it all, and have your copy and have it somewhere else. Have a security plan, okay? Rigor, you gotta have the analysis plan, you gotta have a data management plan. Always state what software you used, always. That matters actually. Believe it or not, that actually matters. Somebody will come back and say, I don't get the same p-value. You produce 0.034, I'm getting 0.045. Maximum likelihood, restricted maximum likelihood. They're both right. But got it? What's going on? I'm at fault. I didn't say when the results were published to that level of detail, we used logistic regression with this estimation process. All right. Version control, that's the other thing I'm always talking about. This is the archiving piece. Just remember to build an archive. If you're not certain when you're getting ready to do it, you don't know what to do, talk to me. So like I said, at a bare minimum, the final analysis data set. It's stored, it's located. The abstract itself is there. I don't like graphical user interface. I don't like point and click systems. I feel like I need to program, because you know why? I can save that program. It will live on. 9 months from now, I pull it up, I hit the button, it's going to go and find that data set and do the exact same set of instructions. 9 months from now, you think you remember exactly where you were pointing and clicking? So be careful there. But just if you do use, they're almost except for things like Excel and that. A lot of the GraphPad, all of these, SPSS, all of them, they do have syntax editors that you should be able to, it will record what it's doing and save it. I know SPSS has that. I need to get into GraphPad to see if it does.
Is GraphPad and Prism the same thing?
Yeah.
Same thing.
So, version control of the databases, and be careful with graphical user interfaces. The bottom line, people cringe at this. If you're doing a small study, transcription errors can matter. Be careful. There's nothing wrong with a little bit of double data entry. That was an old technique we always used. And this is it. Here are the pieces. Final raw data set. Notice I said raw. I've never had a study ever that produced clean data. Even with the best teams out there trying to do the best data management, things still get through the system. You have to take it as is and then adjust it, and then document those adjustments. And then program, prepare the analysis, ready data set, conduct the analysis and the output, all of that in one place with your paper. Okay, I got a publication this morning that notified, congratulations, it's accepted. And I'm like, okay, let's get that paper, put it in the archive. It's done. It is this paper, this version of the paper with this archive. Okay? All right. I think, oh no, I got a few more. What's going on? Oh, always remember, if you've done your own analyses, again, I'm going to tell you the truth. I'm not ashamed. I'm not bothered by people who try to do their own analysis. It's not like I'm sitting around. I've got other things to do. But if you've done it, go find a methodologist. Just say, do you agree with this? I do this with my colleagues all the time. I was on the phone for 2 hours last week with a friend up in North Carolina, great SAS programmer. How would you do this? The answer was, wow, you always bring the tough ones, don't you? And we went back and forth as colleagues. And then when I gave him my code, he said, you've got a mistake here. Thank you. I'm glad. Before we go any further, help me find these things so that you can have greater confidence in the conclusions. So the other thing is just do team science. And this is my last one here, is that it's really kind of building on it. There has been a push in statistics itself outside of what's going on within NIH. If you talk about reproducibility in statistics, what you've got is new packages that are called like an R and in stat, where what they do is they actually produce a version of your paper. So here's your paper. And then when you get to this graph, the graph appears plus the code that generated the graph sitting below it. Why would you need the code? Because the code will tell you which data set it called to build that graph. It will tell you where it was stored. So you're increasing the breadcrumbs for you to be able to follow what you've done. I will say this, in my next career, I'm going to go to work for SAS and try to make theirs better than ours. Ours is very good, but I can't understand why SAS, who already has the ability to drop everything that you produce into a Word document, is not pushing the envelope on this even more by allowing, here is the prop call, here are the results. Margin. And these are the websites where it's all the CCTS stuff. And again, we're always here, and it was interesting yesterday. I'm a little frustrated. I think y'all can tell by my demeanor, a little frustrated by a few things that nothing that y'all have done. Somebody was like, I need this. I had an emergency power calculation yesterday. I really don't believe in emergency power calculations. Staff 911. I don't think anybody's gonna die if you don't get the power calculation done right now. But I didn't have the authority. You heard me say it. I don't have the authority to say, not now. So I stopped to do it. But I found it very interesting. David, that was great. Can you give us a rigor and reproducibility section? I actually thought to myself, well, maybe I have changed something. They know that we need to do this or have a section detailing these things prior to going any further. All right, so again, with all the stats, with all of this, it's drinking from the fire hose. Closing comment. It isn't perfect. Nothing ever is. I do believe in team science. We make it better by being a team instead of trying to do it all ourselves. All right, with that, we'll let you go.